Coming up next on the FRC Open Alliance Show, 7407 Wired Boars is back, and they always bring some great stuff every single year. We'll be diving into their progress, a bit, what they've been doing, showcasing a little bit more in regards to strategic priorities and what they're doing from that. A lot of testing will be showing, including live testing as well, too, which is really, really cool for the different prototypes they've done. We'll even talk about maybe some of the more wacky ideas that Wired Boars has come up with that they might not be moving forward with. We'll also jump in more into odometry, autopathy, and their PhotonVision as well, too, and how they're looking at approaching their Week 2 event. So, learn more about Wired Boars and their progress here in REEFSCAPE coming up on the FRC Open Alliance Show. Let's welcome back on for another year, 7407 Wired Boars coming from Connecticut. Every single year, this team brings some phenomenal things to talk about, and I can't wait to dive more into what their progress is so far. So welcome back on, everybody. If you don't mind, let's introduce yourselves. Let us know what you do in the team. We're going to hop right into many different things, including your strategic priorities, CAD, a bit more as well, too.
Hi, I'm Kate, and I'm a CAD lead.
I'm Max. I'm also a CAD lead.
My name's Hubert. I'm also a CAD lead.
I'm Eben. I'm a programming lead.
Cool. So the first thing we wanted to talk about was our strategic priorities. So coming out of last year, we arguably made a very complicated robot that really didn't do as much as we wanted to. We had like a shooter on an elevator. So we really wanted to try to cut down on what we were doing. So the first thing we decided this year was no ground intake. Last year, we had a lot of issues with it, and it took a lot of impacts, especially because part of ours was outside the bumper. So this year, we're just doing source intake. That was primarily the first thing we decided. The second thing we decided was no algae. So we're completely ditching our attempt to score it at all. We currently want to descore it from the reef just so we can score L3 and L2. Although our main priority for our Week 2 event at Waterbury is mainly just scoring L4, especially in auto, just because it's worth so many points. From that, we had a pretty big team discussion on if we want to do the deep climb or not. Originally, we thought it was going to be pretty hard. On kickoff day, we're like, oh no, that doesn't seem like something we want to try to accomplish. However, coming back, we started a bit later, actually, after kickoff compared to last year. And we saw a lot of teams, the unqualified Quokkas, had a really, really promising deep climb. So after that, we kind of switched up and we're like, yes, we want to do that, especially because those 12 barge points that you get from the deep climb are really important towards the barge RP. So that's where we've decided right now. So we're going to do just source intake, basically no algae, and then scoring L1, L2, L3, L4 coral. So over the past couple of weeks, we've been kind of working towards these goals and deciding how we want to package the robot. So what we've been working on so far and what we've decided is we're doing a 3-stage cascading elevator. So the packaging overall is pretty comparable to what we did last year, which is good for us, mostly just because of how simple it is and how robust we know it is. So that's what we've worked on so far. Other than that, we've decided that our wrist/end effector will have 1 degree of freedom. It basically swings through the elevator. We haven't fully CAD'd this out yet. It swings through the elevator, allowing us to score on all levels with optimal angle. And we'll get more into our testing about that later. Other than that, it's pretty similar. In terms of our intake and climb, they're actually bound together. So they have a simple same axis of rotation. The goal behind this, which you can find more on our Chief Delphi blog, was we want to reduce degrees of freedom on the robot. Last year, this was obviously a struggle. So we're trying to keep things simple. I think that's all pretty much from strategy. I'm going to hand it over to Max, who can talk more about our intake.
So real quick, I just want to ask for you all is, I know that you said you want to keep it simple here, but to me, Wired Boars always comes up with something kind of crazy, at least in concept and stuff. What is maybe something that didn't move forward, but you'd say would classify into that outlandish, like either really cool or outlandish thing that maybe you all came up with?
Yeah, I mean, originally our first idea for the robot was essentially the entire elevator and intake were going to be 4-barred together, and the entire robot was going to be a parallelogram, basically. We really thought through that idea for a while. We thought that was what we were going to go with, mostly because it was really cool and really funny at the same time.
Yeah.
However, when we were sketching through that, we found that the deep climb ended up bringing the cage pretty far into the robot. And that CG was going to be really hard to balance to get the height, especially when we wanted to get the height to climb. So we didn't end up doing that. But I think the intake climb with the climb and the intake rotating together, I think is still pretty fun.
No, really cool. So yeah, let's keep moving on and talk about some of your prototypes you've been doing, your intake testing, things like that. Love to hear more about it.
Yeah, sure. So we started with our intake prototyping. Just doing the most important thing to us was figuring out how to vector the coral correctly. Just dropping from different angles and from different sides. And so we did to test that. We did different angles of the arms going in and out and different neck compressions. And so we started with making like a wooden prototype and just running that on drills. And then we moved to making a more high fidelity one, cutting it at a polycarb. You want to talk about what that looked like?
Sure. Well, in the last week or so, we did a lot of intake prototyping, we created the source for the coral a little like about a week ago or so, and so we've been shoving in coral from all different angles, horizontally, vertically, from out of the slot and in the slot, and seeing like how far we can push the coral in so that it actually vectors into the neck that we want it to. We changed the wheels around from like size 3 to 2. We changed the compression of the wheels, and then more recently we changed the angle the wheels that the wheels vector into the neck. And right now we're working on optimizing using all of the space that we have in the middle of the intake to put like our motors and whatnot.
Yeah, I think we're gonna do a live demo now of the intake. Yeah. So the goal behind the intake was we can intake from any angle across the width of the intake, even horizontal or vertical pieces. The idea is that there doesn't have to be any coordination between the human player and the robot. That just makes our cycles even faster because this is a very much cycle heavy game.
So let me
Kate,
ask,
I think you're gonna
what
talk-
changed because I remember watching a previous video that you had where you put in a piece of coral. We showed it earlier, and that was horizontal, and it got stuck. What changed from that iteration to where you are right now to where you can intake it at any angle?
I would say in terms of horizontal intaking, it really wasn't a priority. So it kind of matters how much velocity you give the coral. So if you push it in horizontally pretty fast, it bounces off the wheels and is able to turn. If you just roll it down there really slow, it can get jammed. But our primary goal is mostly just to intake it in the vertical position. We have been investigating a bit, shooting the coral out horizontally from the intake to score L1. But yeah, the goal is it mainly can just work at any single angle. So if we want to demo it again.
That's really cool. I love the way that's passing through. It's so smooth on there, and I like the idea, by the way, for level 1 coral scoring, if that works for you potentially as well too. I think that's a really cool thing. I think a lot of teams are underestimating how difficult it may be to stack multiple coral pieces or get multiple L1 coral into that. So I love that you're having that full thought process on that. Cool. What else do you want to keep going through?
Yeah, Kate is going to talk a bit more about our X-Take testing.
So, like Huber mentioned earlier, we started a little bit late, so we kind of looked to see what other teams were doing, and initially, like shooting, whether they were shooting it or suctioning it into the X-Take a little bit, or like if they were just going to place it on the coral, shoot it, whatever it was. So we decided to begin with a shooter. Our first prototype was 4 shafts with 2 wheels on them. Kind of janky, made out of wood, but through that process, we figured out what kind of compression that we wanted. And then from there, I think we've just been iterating that design slowly. It's basically the same as what it initially was, but definitely has had a lot of different spacing changes. And I think Max right now is working on that.
Yeah, just moving from the prototyping to like a harder or like a higher fidelity model. I think we started cutting out a polycarb and we started using motors. And then after we started putting that on an elevator and with the right height just to test scoring from different angles and scoring from different sides.
Yeah, the last thing I'll add on terms of the X-Take is we haven't decided how many motors. So obviously, in this robot, in this game, you have to get really high. So any weight on the X-Take is pretty bad in terms of CG. One thing we've been investigating has been how many motors we want to have on the X-Take. We found some success if the 2 sides are differentially driven, which allows you to essentially turn the coral horizontal. So it allows you to score L1 much better than if it was simply just driven out one side. So that's the one thing I think that we're still deciding. Yeah, I think we're gonna do a scoring demo here. Cool. That's our X take. So it allows us to score L1, L2, L3, and L4. L4 we've been testing a 37-degree angle, and that's worked. That's worked very well. I think I'm gonna pass it over to Eben now to talk about some of our programming.
All right, yeah. So all our code is on our GitHub, which is in our Open Alliance post. And one thing I just wanted to talk about is that we code our robot in Python. So we've found that it's useful because it allows the new programmers to get involved really quickly and get caught up because Python, the syntax is not very hard. The downside of Python being that there's not as many resources for it as there are for Java or C++. But over the past few years, we have seen more and more programs migrated to Python. So we've been making use of some of those this year. And one of the things that we are making use of this year that we haven't in the past is PhotonVision. Last year, we used only limelights for our field odometry, but we decided to go with PhotonVision this year so that we can run multiple run more cameras than we could with limelight, have more customizability, stuff like that. And we've had lots of success with it so far on our off-season robot. So hopefully in the next few days, we're going to get it working and like on the field for this game. And for our autos this year, we're going with Choreo and Path Planner Lib, whereas in the past we've used WPI Lib, splines, and holonomic drive controller. We've also found this to be a lot better for us than our methods in the past because it allows for a lot more characterization of the drivetrain. And I think we have a video of that path following. Yeah, and then once we get the vision working with the odometry, we're gonna have like more accuracy. But just from our very preliminary testing, it seems to work very well for us.
What are some of your goals in terms of for your autonomous modes? Like, what do you want to accomplish in auto, or where's your goal set, at least for your week 2 event?
Yeah, so for auto, we want to have like a variety of different autos that we can run so we can kind of be compatible with a lot of different teams. And also having different autos for quals versus elims is something that we're thinking about. It depends on how consistent we are with our different scoring, but like if we were a lot more consistent, say with L1 than we are in L4, in quals, we might want to just dump that first piece straight into L1 to secure that ranking point, and then go for L4 from there. Versus in elims, we want to maximize those points, so just going for L4 every time. And we hope to get, I don't know, we're not quite sure yet how many pieces we'll be able to get in auto, but we're hoping to get 3 or 4 game pieces in auto, yeah. And be able to do it from either side of the field. So be able to score on either side of the reef, depending on what our teammates have for auto.
And I love the idea of having potentially different autos for playoffs as well, too, and just having that full thought process through. I agree. This is a game I think you are going to see different strategies, definitely for playoffs, than what you will in quals, or much more different, I think, as we go through. So, Wired Boars, thank you so much. It's great to have you back on again. Please make sure you're following their build log on Cheat Delphi. They put some amazing work into that and some great resources your teams can look at. And, of course, as mentioned before, you can check out their GitHub and their CAD as well, too. So make sure you're checking that stuff out. But good luck the rest of the way. We can't wait to see you compete in week 2. Thanks a lot.
Thank you.